In this video, I'll show how to apply the passive sign convention, Ohm's law, and Kirchhoff's laws in order to analyze a complete electrical circuit. In this example, I want to write a set of equations from which I can find I, the current through this 1 kilo ohm resistor. The first thing that I need to do is define my variables and their sign conventions. I is positive in this direction, so I'll define a voltage across the 1 kilo ohm resistor, V1, such that I is entering its positive terminal. I can define a voltage V2 across this resistor, in which case the current I2 needs to enter that positive voltage terminal. Finally, I'll do a voltage V3 with its positive terminal down here, in which case I3 needs to be positive in that direction. Now we have 6 unknowns, 1, 2, 3, 4, 5, 6, 3 voltages and 3 currents. I need to write 6 independent equations so that I can solve that for I. Those equations are going to come from KVL, KCL, and Ohm's law. I'll do KVL around this leftmost loop, loop 1 first. If I start down here, going this direction, I see the negative terminal first, so that's at minus 9 volts. I see the positive terminal on V1 next, so that's a positive contribution. And I see the positive terminal on V2 next, so that's a positive contribution. That brings me back to my starting point, so that sums to 0. Next, I think I'll do KVL around this rightmost loop, which I'll call loop 2. If I start down here, I see the negative terminal on V2 first, so that's negative V2. And I see the negative terminal on V3 next, so that's negative V3. I could also loop around this entire outer loop here, loop 3, say. If I start down here, I have a negative 9 volts, I have a positive V1, and I have a negative V3. Sadly, this isn't an independent equation. If I add this equation to this equation, the V2s will cancel out and I'll get this equation. This equation isn't helpful. That's all my options for KVL. Now I can only use KCL next. So let me call this node A. If I say positive currents are leaving the node arbitrarily, I is entering, so I is going to be negative. I2 is leaving, so it will be positive. I3 is entering, so it will be negative. Now I have 1, 2, 3, 4, 5, 6 unknowns and 3 equations. I need 3 more equations. I could do KCL down here. However, there's a current through this 9-volt source that I don't know what it is. So doing KCL here would introduce another unknown, and it would do me no good. I still have 3 Ohm's law cases, though. So V1 is equal to I times 1 kilo ohm. V2 is equal to I2 times 2 kilo ohms. And V3 is equal to I3 times 2 kilo ohms. Now I have 6 equations and 6 unknowns which I can solve to determine I. In this example, I want to find the voltage V. First, I define variables. I'll introduce a variable V1 here and a variable V2 here. If V1 has this polarity, I1 enters this terminal and I2 enters this terminal. Notice that I'm not using V as one of my variables. What will finally end up is that this voltage and this voltage are the same, so one of my equations will be V is equal to V2. Now, let's do Ohm's law. So V1 is equal to 3 ohms times I1. And V2 is equal to 2 ohms times I2. Those are 2 equations. I have 4 unknowns. Now I have one loop that I can do KVL. So let me loop this direction. So negative 5 volts plus V1 plus V2 is equal to 0. Finally, KCL here at node A results in minus, and if I use positive currents leaving the node, I2 will be positive and I1 will be negative. So negative I1 plus I2 is equal to 0. Now I can solve these equations, including V is equal to V2, to find that V2 is equal to 2 volts. Now let's do a different sign convention here and try the problem again. Now I'm going to try doing the same problem with an alternate variable definition. I'm going to stick with V1 being defined this way, so this is I1, but I'm going to swap my polarity on V2. Remember that I get to choose either the voltage polarity or the current direction arbitrarily. That means that I2 will be entering this terminal. Now V2 has the opposite polarity as V, so V is going to be the negative of V2. Now I have 4 unknowns. 4 equations are necessary to solve for that. I'll start out with KCL again. If I do KCL at this node here, KCL at A says if positive currents are entering the node, I2 plus I1 is equal to 0, so one or the other of these is going to have to be negative. Now if I do KVL around my loop again, I get negative 5 volts plus V1 minus V2 is equal to 0. Ohm's law tells me that V1 is equal to 3 ohms times I1, and V2 is 2 ohms times I2. If I solve these equations for V2, I get V2 is equal to negative 2 volts. But since V is the negative of V2, V is positive 2 volts, which is the same answer as I got before, which it needs to be. This video shows how to apply the passive sign convention, Ohm's law, and Kirchhoff's law together in order to analyze an electrical circuit.